Welcome to Unit 4, Lesson 12, Arithmetic with Complex Numbers Practice Problems. Okay, so what we're going to do is when you see a negative under a square root, separate that into -1 times 4. So this is 2 times the square root of -1 times 4. The square root of 4 is 2, so this becomes 2 times 2. The square root of -1 is I. So this becomes 4i. I'm not going to worry about plotting it on the graph. Okay? So 3i times 2i equals 2i, not 2. I'm writing too fast. Okay, 3 times 2 is 6. I times I is I squared. Since I squared is -1, this becomes 6 times -1, which is -6. Now, I to the 4th is just 1. That's all it is. There's nothing else to do. And then finally, D is a full complex number, 4 minus 3i. C was a real number, B was a real number, and A was purely imaginary. It had no real part to it, so it wasn't complex. Or sometimes you will see A written like 0, because 0 is a number, plus 4i. If you wrote it as a complex number. 0 is a real number. Okay, which expression is equivalent to this addition problem? So now the first thing you do is distribute the negative. So this becomes 3 plus 9i plus -5 plus 3i. Now, after we sort out the subtraction, put your real numbers with your real numbers and your imaginary numbers with your imaginary numbers, and we get -2 plus 12i, which leaves us with B. Okay, what are A and B when you write the square root of -16 in the form of A plus BI, where A and B are real numbers? All right, so the square root of -16 becomes the square root of -1 times 16. The square root of 16 is 4. The square root of -1 is I. We have a purely imaginary number. So A is 0. This is 0 plus 4i. So A is 0, and then B is 4. So B is the best answer. Okay, now fill in the boxes. So what we're going to have to do here is separate. But no, the first thing we're going to do, before we separate, the first thing we're going to do is distribute the negative. Distribute this negative. All right, so this becomes -15 minus box I. All right, now that we've done that, what we're going to do is take and separate the reals with the reals. So box plus -15 or -15. So I'm going to get rid of the 2 signs. I'm going to write 1 sign and write -15 equals 7. And then I'm going to write -3i plus -I, which is negative again. So it's just minus again. Minus box I equals -12i. Okay. What -15 is 7? I'm not sure. But one thing I do know about subtraction is that you can go the opposite way. If you're subtracting going right, add going left. 7 plus 15 is 22. So that might mean the number is 22 minus 3i for the first one. Minus, okay. Since subtraction going left, you can add going right. Oh, this is kind of screwy. All right. -3 minus what number is 12? I know that same signs add, so I'm going to ignore the negatives, and I'll say 3 plus what number is 12? Well, 3 plus 9 is 12. So that makes the second one 15 plus negative 9i, which is minus 9i. No, that's plus because the negative is outside. I'm sorry, we got to change the sign because the negative is outside. And then after we change the sign, things look a little bit better. And we put the real numbers with the real numbers and the imaginary numbers with the imaginary numbers, and we should get 7 and negative 12i, which we get. Okay, plot each number on a real number line. So the square root of 16 is 4. So we're going to deal with the primary roots. The opposite of the square root of 16 is negative 4. The negative stays outside, and the square root of 16 is 4, so that goes there. This is not real. The square root of 56. Since the square root of 56 is in between 49 and 64, it's probably about 7.5. It's about halfway. So what this means is, let's do this. I forgot to do this in orange. This means the square root of 56. So 49 is 7 away, 64 is 8 away. So it's probably halfway between 7 and 8. So that goes there. Now, negative 56 to the 1/2. See, the way PEMDAS works is this is treated as negative 1 times 56. So the calculator and PEMDAS will say deal with the exponent first. So this is negative root 56, or the opposite of root 56, which is in between 7 and 8, about halfway. Now, the last one, because this is inside the parentheses, this is negative 56 inside the root. And we know this is imaginary, so this is not real. Because roots of negative numbers are not real. Okay, which expression is equivalent to negative 4? Separate negative 4, negative 1 times 4. This becomes 2i. C.